In this video, let's go ahead and do some practice problems dealing with opposites, absolute values, the coordinate plane, and operations with rational numbers. And real quick before we get started, if you'd like to download a blank copy of this PDF, you can find a link to that below. And with that link below, you can also find a bunch of other resources for other topics that you can use as well if you want to. All right, let's take a look at number one here. All right, for number one, we're going to go ahead and rewrite a bunch of these rational numbers as decimals. So some are decimals, some are fractions. The ones that are fractions we'll rewrite as decimals. But we're going to go ahead and use the division standard algorithm to do so. Then we're going to compare them, and we're going to order them from greatest to least instead of least to greatest. And we're also going to make sure that we're using inequality symbols to do so. Now remember, when we are ordering these from greatest to least, that we're ordering the original rational numbers, not all the decimals that we find. But we're going to go ahead and make sure we use the original values. All right, so for A, this negative 1.7 is already a decimal, so I'm going to leave that one alone. And this negative 2.6 is also already a decimal, so we don't really have to do anything with those ones, right? As for this negative 1 3/4, that's a mixed number, so let's turn it into a decimal. First though, we're going to go ahead and turn that into an improper fraction, so negative 1 3/4 is going to be the same thing as negative 7/4, okay? And what does that mean? That means that we're going to do 7 divided by 4 to figure out that decimal. So let's go ahead and put the 7 inside the house and then the 4 outside. 4 goes into 7 once. 1 times 4 is 4. We're going to get a remainder of 3 here. All right, go ahead and put 2 decimal points and add a 0 inside that division house. Bring down that 0. 4 into 30 is going to be 7. 7 times 4 is 28. 30 minus 28, that's going to be 2. Let's go ahead and add a 0 and bring it down. 4 into 20 is going to be 5. 5 times 4 is 20. We see here that we're going to get a remainder of 0. So this is going to be negative 1 75/100. That's the same thing as negative 1 3/4. So that's using our long division. Now what about this negative 2 1/2? So let's go ahead and see what that's going to look like. So as an improper fraction, that's going to be negative 5/2, right? So there's just some work that we have to do on the side here. Let's see, I'm going to go ahead and put the 5 inside the house, because again, this is 5 divided by 2. 2 goes into 5 2 times, right? 2 times 2 is going to be 4. 5 minus 4 is going to be 1. Let's go ahead and put 2 decimals and a 0. Let's see, 2 into 10 is going to be 5 times, so 5 times 2 is 10. We get a remainder here of 0. Okay, let's go ahead and just take this work and just put it on the side here. So that's that, and this is this. I'm just going to leave it on the side though. Okay, so that was our long division. Maybe make it a little bigger so you can still see it if you want to. And so this decimal is going to be negative 2.5. All right, now we want everything to have the same number of decimal places, so we can rewrite this negative 1.7 as negative 1.70. This negative 2.5 we can say is negative 2.50, and for negative 2.6 we can say it's negative 2.60. All right, so now that we have these all as decimals, we're trying to figure out them in order from greatest to least. So we have to find the smallest absolute value here. So I think that's going to be this one over here. So I'm going to go ahead and write, this is going to be negative 1.7, right, the original value. That's going to be greater than which one? So we took care of negative 1.7. I think it's greater than negative 1 3/4. Negative 1 3/4. That's going to be greater than which one? I think it's going to be negative 2 1/2. Negative 2 1/2. And that should be greater than this negative 2.6. So that's the smallest value. Again, there's not a ton of space here, so if you are doing your long division, feel free to do it on a separate piece of paper and just staple it to this piece of paper, or just do it on the side if you can squeeze it in. But you definitely want to make sure that you can turn these fractions into decimals. All right, here is B. For B, it looks like we have 1 decimal here, which is really nice, so we don't have to do anything with this one, but the other ones are all fractions, so let's go ahead and figure out what they are as decimals. So we have negative 7 3/8. So as an improper fraction, 7 times 8 is 56. 56 plus 3 is going to be 59. So we really have negative 59/8. All right, so let's do 59 divided by 8 here. Let's do 59 inside the house, and let's put 8 outside. So 8 goes into 59 7 times. 7 times 8 is 56. Then we can see here we have a remainder of 3. Put a decimal, a 0. Bring the 0 down. 8 into 30 is going to be 3 times. 3 times 8 is 24. 30 minus 24, we have a remainder of 6. So add another 0 and bring it down. 8 into 60, that's going to be 7. 7 times 8 is 56. 60 minus 56 is going to be 4. To add another 0, bring that down. So this is 40. 8 into 40 is going to be 5 times. 5 times 8 is 40. You can see we have a remainder of 0. So here for negative 7 3/8, that's negative 7.375, right? That's the decimal version here, all right? Let's go ahead and take this and just make it a little smaller, get some more room here so that we can actually do some other calculations. And over here, we have negative 7 1/3. What's that the same thing as? That's the same thing as negative 7 times 3 is 21 plus 1 is 22. So that's 22 over 3, right? All right, so we're gonna do 22 divided by 3 here. It's gonna go in 7 times. 7 times 3 is 21. We have a remainder of 1. Decimal, 0. Bring the 0 down. 3 into 10 is gonna be 3 times. 3 times 3 is 9. We're gonna get a remainder of 1. And this is just gonna keep repeating itself over and over again, right? So we're gonna put another 3, so on and so forth. So we know it's gonna be 7.3 repeater. So this is gonna be negative 7.3 with a bar on top of it. So that 3 goes on forever. Okay, let's go ahead and take this and put it on the side here. All right, we have one more fraction to deal with here, this negative 7 2/5. As an improper fraction, 7 times 5 is 35, plus 2 is 37, so this is negative 37 over 5, right? So what does that division look like? Well, it's going to be 37 divided by 5. 5 fits into 37 7 times, which makes sense because that's the whole number. That's 35. We get a remainder of 2. Decimal, 0, bring down the 0. 5 into 20 is going to be 4 times. 4 times 5 is 20, so we get a remainder here of 0. So this is going to be negative 7.4. All right, that's that decimal version. So now we have all our decimals. Put this over on the side as well. And we can actually start comparing here. We do have this negative 7.3 as well. So we have all decimals. And notice how we have 3 decimal places for this negative 7.375. So we can add decimal places here. So 0.300. For the negative 7.3 repeater, the next 2 digits are going to be 3s. And then for this negative 7.4, the next 2 digits are going to be 0s. So which of these decimals is the biggest or the greatest value? Well, it's going to be the one that's closest to 0 since they're all negative here. So I believe this negative 7.3 is going to be the greatest value. And then we have this negative 7 1/3. That's going to be a little bit smaller. And then what we have next is going to be negative 7 3/8. That's a little bit smaller as well. And then finally we have this negative 7 2/5. This one is going to be the smallest one because it has the greatest absolute value. It's furthest to the left on the number line out of these 4 rational numbers. All right, here is C. For C, we have a couple nice rational numbers here that we don't have to change. So we have this negative 5.7, that's already decimal, leave it alone. Then we have this negative 4, which is just a whole number. So we can always just add a decimal point and some zeros after that. Now let's go ahead and convert this negative 5 2/3. That's really negative 17 over 3, right? And so that's 17 divided by 3. Feel free to do this on the side somewhere, but 3 into 17 is 5 times. 5 times 3 is 15. 17 minus 15 is going to be 2. Decimal, 0. Bring down the 0 here. 3 into 20 is going to be 6 times. 6 times 3 is 18. Notice we have a remainder of 2, which is going to repeat itself here. So it's going to be another 6, and it's going to go on forever, right? So this is going to be 5.6 repeater as a decimal. Put that on the side here. So this must mean it's negative 5.6, and then it's going to be 6s going on forever after that. All right, moving on to this negative 5 4/5 here. As an improper fraction, that's going to be negative 29 over 5. Okay, and so what does that really mean? That is just 29 divided by 5. Let's go ahead and put 29 inside, 5 outside. 5 into 29 is going to be 5 times. 5 times 5 is 25. The remainder here is 4. Put a decimal, 0. Bring that 0 down. 5 into 40 is going to be 8 times. 8 times 5 is 40. We have a remainder of 0. Okay, so this is going to be negative 5.8. All right, that's what negative 5 4/5 is. And this we can also just get some more space here, right? So if we look at this negative 5.7, that is already good to go. Then we have this negative 4. I'm just going to write negative 4.0 just so everything's a decimal here. Out of all these, which one is the biggest? I think it's going to be negative 4, right? That's the least negative value. And then that's going to be bigger than negative 5 2/3. Again, make sure you're writing the original values. That's going to be greater than negative 5.7. And that's greater than negative 5 4/5, which is the smallest one out of all of these. Alrighty, so for D, we have another set of rational numbers here. We have this negative 2.6. This one is good to go. And then we have this negative 2.5. That's also already a decimal, so we can leave that one alone as well. We have two fractions here. Let's take a look at this negative 2 5/11. As an improper fraction, that's going to be negative 22 plus 5, negative 27 over 11. So what's that division going to look like? Well, let's go ahead and put 27 inside here, 11 outside. So 11 fits into 27 two times. Put the 2 on top of the 7. 2 times 11 is 22. We get a remainder of 5, which should make sense. And then put a decimal, and a 0. Bring that 0 down, so we have a 50 here. 11 into 50, it's going to be 4 times. 4 times 11 is 44. We have a remainder of 6. Then we can add another 0 here and bring it down. 11 into 60 is going to be 5 times. 5 times 11 is 55. We're going to get a remainder here of 5, right? Notice how that we had a remainder of 5 earlier, so this is going to repeat. It's going to be 2.45454545 forever. So I'm going to go ahead and write that this is going to be negative 2.45 245 hundredths, and put a bar over both numbers because both numbers are going to repeat over and over and over. Okay, so that's what this negative 2 5/11 is as a decimal. Let's take a look at this negative 2 2/3. Hopefully you've seen this 2/3 more often here, but as an improper fraction, that's going to be negative 8 over 3, right? And so as a division problem, that's going to be 8 divided by 3. So the thirds are a lot more common, I think, that people see more often than the 11ths. 3 into 8 is going to be 2 times. 2 times 3 is 6. 8 minus 6 is going to be 2. Let's put a decimal, 0. Bring the 0 down. 3 into 20 is going to be 6 times. 6 times 3 is 18. 20 minus 18 is going to be 2. And we're going to have another 0 and bring that down. This is just going to keep repeating, so it's going to be 6's forever here. So this is going to be negative 2.6. And the 6s are going to keep repeating forever, right? So it's one of those repeater decimals, just like the 11ths are. And so now we have these decimals. Let's go ahead and write them down and compare their place values. So we have negative 2.6. I'm going to add a 0 here just because negative 2.45 has 2 decimal places. I'm going to add another 6 to this negative 2.6 repeater just so we have matching decimal places again. And then I'm going to make this negative 2.50. Okay, so we can kind of compare here. So out of all these, which one is the greatest? Well, they're all negative. So we're going to find the one with the smallest absolute value here. So I think it's going to be negative 2 5/11. All right, that's going to be the biggest one here. And then we have that's greater than negative 2.5. That's the next greatest one. Then we have negative 2.6. Okay, that's going to be the next greatest one. And then the one that's going to be the next greatest, or rather the smallest one here, is going to be this negative 2 2/3. That's going to be the smallest out of all of these. All right, here's number 2. Looking at these pair of points, we're going to find the distance using absolute values. So let's make sure that we are using absolute values to kind of show that work and understanding here. So let's see, we have point A and point B. It looks like they're going to be in different quadrants. So notice here that we have this negative 6 and negative 6, so their x values match. That means these 2 points are vertical to each other. But if we take a look at this 4 and this negative 7, they're in different quadrants. So how do we show the distance between them if they are in different quadrants? Well, we're going to go ahead and take the absolute value of this 4, and then we're going to go ahead and add on the absolute value of this negative 7, right? That's what we're going to do if they're in different quadrants because they're on opposite sides of 0. Now the absolute value of 4 is 4. The absolute value of negative 7 is just positive 7. 4 plus 7, that's going to be 11 units apart. Okay, so that's going to be how far these 2 points are from each other. Now, if we look at B, we have points C and D. These 2 points are actually also vertical to each other because they have matching x values or x coordinates again. So if that's the case, we're just going to look at their y values to find the distance between them. Now, they are both negative, so they're in the same quadrant. If they're on the same side as 0, to find the distance between them, you go ahead and take the absolute value of the one that is further from 0, and you subtract the absolute value of the one that is closer to 0, right? This way we get a positive distance. So the absolute value of negative 15 is 15. 15. The absolute value of negative 7 is 7, so 15 minus 7 is going to be 8. So these 2 points are 8 units apart. All right, and if you want to check that, feel free to plot these on a coordinate plane and look at it and see that they are indeed 8 units apart from each other. All right, let's take a look at number 3. All right, for number 3, we are looking at these expressions, and we're told that a and b, which are these variables, are going to be representing negative integers, right? That's what they have to be. We have to come up with hypothetical values, so we have to come up with a value for a and b so that we can make each of these inequalities true. So we could have definitely different answers to these problems, so make sure that you're thinking about what you would put for these, because these are just hypothetical. There's more than one right answer, potentially, for most of these. All right, so for a here, a has to be less than b. Okay, so we have to make up a number for a and a number for b. They both have to be negative, but a has to be less than b. All right, so what could we choose for these values? So maybe we could choose something like a is equal to negative 14, right? Now, if I chose a is negative 14 and it has to be less than whatever b is, I'm going to choose b is going to equal to negative, I don't know, it doesn't really matter, but as long as it's greater than it, I'm going to choose negative 10. So if this was true, I think this would make sense, just because if you were to look at this, we could then substitute in and say that negative 14 would indeed be less than this negative 10. All right, now were you supposed to choose the same exact numbers as me? No, you should have come up with some other 2 numbers, unless you watched this perfectly. Now, you should have chosen different numbers because I just chose these 2 random ones, but as long as your a value is less than your b value, then that would have been true. Let's take a look at b now. This one's more interesting. So we have negative a has to be less than b. Now, negative a really just means the opposite of a, right? Now, we know a is going to be a negative number. So what is going to be the opposite of a negative number? Well, negative a, or the opposite of a, has to be a positive number, right? Now, what's b? Now, we said earlier that b, for all of these, has to be a negative number. So I guess the question is could we ever have a positive number that's going to be less than a negative number? And I think that's going to be impossible. So in this particular case, this one is not going to be possible. You could not come up with any numbers or integers that are negative for a and b that would make this true, right? No matter what we choose for a and b, we're going to get that a positive number would be less than a negative number, and that's not possible. All right, for C, we have a is less than the absolute value of b. So a, this is definitely going to be a negative number here. So I'm going to go ahead and say this has to be negative. All right, so that's definitely going to be negative. But then what about the absolute value of b? Well, b is a negative number, but the absolute value of a negative number is always going to be a positive number. So is this possible? Yeah, I think so, right? Because negatives are going to be smaller than positives here. So I'm going to go ahead and say here that a could equal something like, I don't know, negative 5, right? And then maybe b is going to be something just like equal to negative 1, right? As long as we know we're going to be taking the absolute value, then it's going to be positive. So we can go ahead and write this as a would be negative 5 in this case, and this would be less than the absolute value of negative 1, which is just positive 1. So this does seem to work out here, because we would say negative 5 is less than positive 1. I didn't write this earlier, but this has to be a negative number here, and this has to be a negative number here as well. So for this first one, for a, we just had to choose a negative number that was smaller than the second negative number, or a had to be smaller than b. So hopefully that one is more clear though. All right, for D, what do we have here? We have b is going to be greater than the absolute value of a. Now again, we know b is going to be a negative number here, right? So this is going to be negative. But what do we know about the absolute value of a? Well, a is a negative number, but the absolute value of a negative number is always going to be a positive number. So I guess the question here is it possible for a negative number to be greater than a positive number? And I'm going to argue that that is not possible, right? Because all positive numbers are going to be greater than all negative numbers. So here we're going to say that this one is going to be not possible. All right, for E, we have the absolute value of a is greater than the absolute value of b. Now, a is going to be a negative number, but the absolute value of a negative number is going to be a positive number. B is also a negative integer, and if we take the absolute value, that this is going to be positive as well. So how could we do this? Well, a positive number can definitely be bigger than a positive number. So what could we come up with the values for a and b here? Now, a has to be greater, absolute value of a has to be greater than the absolute value of b. So I'm thinking a could be equal to like negative 25. Remember, these have to be negative numbers. And then b here could be equal to like negative 21 here, right? So if we were to go to plug this in so I can show you that this does work, we would do the absolute value of a, which is going to be the absolute value of negative 25, and that's got to be greater than the absolute value of negative 21, right? And so we check this is equal to 25, this is equal to 21, and 25 is bigger than 21, so this does make sense. For f, we have this opposite of b, or negative b, has to be greater than negative a, or the opposite of a. All right, so over here, we know b is a negative integer, but it's the opposite of a negative, so this is guaranteed to be a positive value. And here a is negative and the opposite of negative is a positive, so this is guaranteed to be a positive number, right? So we have positive is greater than a positive here, so what would the values of a and b be? So a here, we could say is going to be something like, I don't know, negative 4, and then b would be something like negative, I don't know, we could say negative 9. Right? So would this hold true here based on what we're saying here? So the opposite of b, this would be opposite of negative 9. Would that be greater than the opposite of negative 4? I think this is going to hold true, right? Because the opposite of negative 9 is going to be 9, and then the opposite of this negative 4 is going to be 4, so 9 would be greater than 4. All right, so as long as you chose a bigger number for a and a smaller number for b, this is going to hold true with both of them being negative integers. All right, here is number 4. For number 4, we're going to be talking about reflections here. So we're going to be flipping some points across the x and the y axis, and then we're going to go ahead and write the coordinates of this new image for each of these in particular. Okay, so for part A here, we're going to be reflecting this point of 4, 6. We're going to reflect it across the y-axis. Now remember, when you reflect things across the y-axis, then the image is always going to have the opposite x value. So the image for A, or A prime here, is going to be negative 4, positive 6. All right, so that's across the y-axis. Feel free to sketch this out if you'd like to kind of see it a little bit more clearly, but every time you flip across the y-axis or reflect, the x values or x coordinates are going to be the opposite value. For B, we have this point for point B of negative 6, 2. We're going to reflect this across the x-axis, which means we're going to be writing the opposite y value here. So the image here, or B prime, is going to be the same x coordinate of negative 6, but the y coordinate is going to be the opposite of 2, which is negative 2. For C, we're going to reflect point C, this negative 3, 7, across both the x-axis and the y-axis. Now, whenever you do that, then the image is always going to be the opposite x and y coordinate. So C prime here, the opposite of negative 3 is going to be 3, and the opposite of this 7 is going to be negative 7. So whenever you reflect a point across both x and the y-axis, both x coordinate and y coordinate are going to have the opposite value. For D, let's reflect D, which is 9, negative 4, across both the y and the x-axis, so across both again. So where's D prime going to be located? D prime is going to be at negative 9, positive 4, because it's the opposite of both the x-coordinate and the y-coordinate. All right, so for number 5, we're going to go ahead and state the type of reflection that must have occurred from each of the pre-images to the images. So we have the pre-images, which is the original location of the point, and then we have the image, which is where it's been reflected to. So let's take a look and see if we can identify what type of reflection was made. So for E, this one ended up at E prime. So let's see what kind of things changed from E to E prime here. So notice that we have this negative 5, and it's going to stay as a negative 5 here. So the x coordinates do not change here, right? If the x coordinates don't change, that means it's not going to be a reflection across both axes. And also we know it's not going to be a reflection across the y axis. So let's go ahead and see, what about the y coordinates here? So the y coordinates here are going to be 2 1/4, and this is actually negative 2 1/4, right? If we go ahead and think about that as a fraction, or you can convert each of these to a fraction or a decimal, but this is also negative 2 1/4. So notice that the y coordinates are the opposite here. So whenever we have opposite y coordinates, so if we have opposite y coordinates, that means this point must have been moved up and down. So this is going to be an x-axis reflection. All right, what about B? If we look at B, we had these 2 points here of F, and it got reflected to F prime. Let's take a look and see what we can find out about their coordinates. So look at this X coordinate, it says -2 and 75/100ths. This is +2 and 3/4. Now this -2 and 3/4 and this -2 and 75/100ths, you can go ahead and convert them, but these are identical in terms of their value. So they are opposites though, right? So we have opposite X coordinates. So if we have opposite X coordinates, that's going to tell us that we have a type of reflection that's going to be across the Y axis, right? But it could have another set of reflections. So let's see here. Here we have this -1 and 2/5, and we have this 1.4. This 1.4 is also 1 and 2/5, right? So again, up to you to turn these into both decimals or fractions to compare here. But notice that we actually have opposite X coordinates here, but we also have opposite Y coordinates here. So in order for point F to become point F prime, or its image, point F must have been reflected across both axes. All right, for C, we have this point G over here, and it's reflected to G prime over here. Let's kind of see what's going on with those coordinates here. So this X coordinate is +3.5. This is going to be an X coordinate of -3.5, right? So this is +3.5. That's -3.5. So we must have had some reflection here across one of the axes at least, right? So we already see that the X coordinates are opposite values. So I'm going to go ahead and just say that we know that, because that's going to let us know that we have at least a reflection across the Y axis. But let's check the Y coordinates here. So this is -6.25. This is also -6.25. So this is -6 1/4. Because these are the same, then we're not going to have a reflection that's going to be across the X axis. So if we just have opposite X coordinates, that means we have an X axis reflection, or reflection across the X axis. All right, for D, we have H. This is the pre-image, or the original, and this is going to be the image after it's been reflected. Let's take a look at its coordinates. So starting with the X coordinates, we have 8 3/10, and this is -8 3/10, right? So these are opposite values here. So we have 8 3/10 comparing to -8 3/10. So we can see here that we have opposite X coordinates here, which lets us know that we at least have a reflection across the Y axis. And then if we take a look at this -3 3/8 and this +3 3/8, well, these are definitely opposites here. But this 3 3/8 is the same thing as this 3.375. So you can go ahead and do the division to kind of check that. But you can see that these are actually also opposite values. So you can see we also have opposite Y coordinates. So if we have both opposite X and opposite Y coordinates, then we must know that H to H prime here, or the pre-image to the image, must have been a reflection across both axes. Alrighty, let's take a look at number 6. Here we're going to be done talking about reflections for now, but we're talking about moving some points and finding distance as well away from given points here, right? So we need to write the ordered pairs, which is just x comma y, of 4 different points. These have to be given a certain distance away from each of the points here. So let's take a look. For A, we have 7 units away from this point over here. So let's see, if we can go 7 units away, we could go 7 up, 7 down, 7 left, and 7 to the right. So let's see, the first thing I'm going to do here is let's actually go left, right? So if we go left, then we just have to be looking at the x coordinate here. So if we have -4, but we move to the left, that's going to say that we're going to the left, so subtract 7. This would be -4 plus -7, and this would end up at -11, right? So one of these points here could be at the coordinates of -11, comma, +6. Okay, that's to the left. What if we want to go to the right? Well, we could take this -4 and then add 7. That's going to go to the right. That's going to end up at +3. So if we do that, then this coordinate here is going to end up at +3, comma, +6. So this point here would be to the left. This point over here would be to the right, because we went 7 to the left and 7 to the right of the x coordinate. What about up and down? Well, we can go from 6 here, right? If we start at 6, what if we go down first? If we take away 7, 6 minus 7 is the same thing as 6 plus -7. And you can look at this on a number line too if you want, but this would be -1. So if we went down 7 units, then the x coordinate would stay the same here, but we would have a y coordinate of -1 instead. And this would be us going down here. Okay, and then finally, what if we were at this 6 but we went up 7 instead? 6 plus 7, that's going to equal 13. So what are the coordinates here going to be? Well, it's going to have the same x coordinate because we're not moving left and right, we're just moving up and down. But the new y coordinate is going to be positive 13, and that's if we moved up 7 units instead. All right, for B, we're going to go 4 units away from this point R of 0, negative 3. Let's kind of do the same thing here. Let's just move left and right, then move down and up afterwards. So let's start with the 0, the x-coordinate, because that's going to be the left and right movement. So if we're at 0 here, but we go down 4, 0 take away 4, that's going to be 0 plus negative 4. That's going to be the same thing as negative 4 here, right? So if we move 4 to the left, our new coordinates are going to be negative 4, negative 3. All right, what if we start at 0 here, but we move 4 to the right? That's going to be 0 plus 4, so 0 plus 4 is just going to be 4. I don't know why I wrote that twice, but I did. And we're going to have this as 4, negative 3 here, right? So this was to the left 4, this was to the right 4 from where we started. What about moving up and down? Well, that's only going to affect the y coordinates here, so we're starting at negative 3. So we're at negative 3, but what if we go down 4 here? If we go down 4, that's going to be negative 3 plus negative 4. That's going to be negative 7. So what is our new coordinates if we go down 4? Well, it's going to be at 0. That stays the same as the original, and it's going to be negative 7. All right, that's going to be down. What if we go up? Well, we take the y coordinate and we add 4. Negative 3 plus 4 is just going to be positive 1. So that's going to be saying that we're going to be at 0, positive 1. So this is if we went down, and this is if we went up. So these would be our 4 coordinates of points that are 4 units away from the original point. All right, for C, let's move 8.5 units away from K here. So we're going to go in the same order of left, right, up, and down here. So let's start with just the left and right. Let's look at the x coordinate. So if we have negative 4 here, let's move to the left. If we move to the left, we're going to take away 8.5. So this is the same thing as negative 4 plus negative 8.5. If we add these, we're going to end up with negative 12.5. So it's going to be negative 12.5. 1. We keep the same y coordinate there. Now, if we want to go to the right, we take this x coordinate and we add 8.5 here. If we're adding a negative plus a positive, we actually subtract. So 8.5 minus 4 is going to be positive 4.5. So if we look at these new coordinates here, this is going to be positive 4.5, 1, right? So the first one we went to the left, and the second one we went to the right. Looking at the y coordinate of 1, let's go up and down. Let's go down first, just like we did in the last view though. So let's go take this 1. Let's go down to take away 8.5. This is going to be the same thing as 1 plus negative 8.5. All right, so we're going to have to subtract these. So 8.5 minus 1 is 7.5. So let's go ahead and keep this negative 4 as the x coordinate, but it's going to be negative 7.5 for the y coordinate here, right? Because that's going to be 8.5 below wherever 1 is. What if we moved up? So let's take that y coordinate of 1 and add 8.5. This one's a little bit easier, I think, right? So 1 plus 8.5 is 9.5. And so we have this 9.5 here. And so we're going to keep the x coordinate of negative 4, but the y coordinate is going to be now positive 9.5. The one we just did above it, that's going to be below by 8.5 units. The one we just did is going to be above. So I'm going to say that's up instead of down. All right, one final example similar to these, we have 3.75 units away from L, which is at negative 6.25, 4.5. So we've got some more decimals here, but the concept remains the same. So let's go start with like left and right here. So let's go ahead and take a look at the x coordinate. This is left and right. Let's go to the left first. So let's take this negative 6.25. If we're going 3.75 units to the left, we're going to subtract. So minus 3.75. This is the same thing as negative 6.25 plus negative 3.75. So if we add those, that's actually going to be negative 10. So this is going to be negative 10, 4.5. Leave that y coordinate alone. So that's going to be going to the left. If we're going to go to the right, we're going to take this original negative 6.25 and we're going to add 3.75 instead. Right? So if we add here, we're actually going to be subtracting their absolute values. And if we subtract their absolute values, that's going to end up being negative 2.5 or negative 2.50. And so the new coordinates here are going to be negative 2.5, 4.5. So this one was to the left and this one was to the right. All right, let's move on and figure out the point that's going to be below and above. So if we're starting at 4.5 here, let's take that y coordinate of 4.5. Let's go down first. Let's take away 3.75 and go below it. If we do that, that's going to be 4.5 plus a negative 3.75. If we go ahead and do that, we're basically just subtracting. So we could have kept it as subtraction if you wanted to. So the x coordinate here is going to stay the same. So we're going to have negative 6.25. Leave that alone, but then we're going to have, I think 4.5 plus negative 3.75 is just going to be positive 0.75. So that's if you just subtract, and that's going to be below here. Now what if we go above? We take this 4.5, but we go above it. We add 3.75. So I think if we add these, we're going to end up with 8.25. All right, so if we go above, we're going to keep the negative 6.25. And then we're going to have a positive 8.25 for the y coordinate. So this one we just did above, that was if we went below it, we went down. And this one is when we went up. All right, that wraps up these 4 different practice problems with figuring out points above, below, left, and right, and given a specific distance. So let's take a look at some word problems here. All right, let's take a look at number 7. In number 7, Princeton Middle School is installing a fence. If it's fence, it's going to be going around the outside or the perimeter of some type of shape here. It looks like it's going to be a new rectangular field, so we know it's a rectangle. Students are going to be able to play safely outside on this field next to a busy street. The architect plans out the installation of the fence by plotting a sketch on the coordinate plane. So let's take a look at part A, which is going to be making an accurate sketch of this on the coordinate plane below. Okay, so first thing we have here is going to be corner 1. Corner 1 is going to be point P here, which is going to be 7, 8. So it goes 7 to the right and 8 up. That's going to be in quadrant 1. Go ahead and plot that down. That's going to be right around here. And then we have corner number 2 here. That's L. It's going to be 7, 1. So let's go 7 to the right and then up 1. That's going to be L. And then we have quarter number 3, which is A, which is negative 9, positive 1. Let's go over here in quadrant 2. That's going to be A. And then we have Y, which is going to be negative 9, positive 8. That should be in quadrant 2 as well, but above point A, because they have matching X coordinates, right? So it's going to be Y. All right, we have all 4 points here. Now that we have these 4 points, let's go ahead and just connect these real quick. All right, so here is what this rectangular field is going to look like. These lines connecting the corners are going to be where the fence is going to be. And this area inside is going to be where all the students are going to be playing. Now we're going to be going ahead and finding out the area and perimeter of this in part B and C. So while we have the space here, I'm going to go ahead and just figure out some measurements here. All right, so let's go ahead and label this as maybe the length of this rectangle here. So A to L is going to be the length. And then I'm going to go ahead and call A to Y the width here. Again, doesn't really matter. You can switch L and W if you would like to, but let's go ahead and see if we can find the length and the width here. So starting with the length here, that's going to be this measurement from A to L, or you can do from Y to P. They're both the same thing, so up to you. But let's see here for the length. I'm going to go ahead and say the length is going to be the distance between A to L, or segment AL. Now they're in different quadrants here, so let's go ahead and look at their absolute values. We have negative 9 and we have 7 here. So they're in different quadrants. We're going to take the absolute value of negative 9 plus the absolute value of 7. So that's going to be 9 plus 7, which we know is going to be 16 units. All right, so that's the distance between A to L, or the length of this rectangle. All right, what about the width? Well, the width here is going to be the distance here from A to Y, or Y to A, which is the same as P to L. All right, they're in the same quadrant now, so I'm going to go ahead and write Y to A, but feel free to write the other segment if you want as well. So from Y to A, let's check this out. They're in the same quadrant, so looks like Y is up here at 8, and A is down here at 1. So if they're in the same quadrant, take the one with the greater absolute value, which is 8, and subtract the one with the lesser absolute value, which is 1. That's going to be 8 minus 1, and so that's going to be a distance of 7 units between A to Y. So we know the width here is going to be 7 units. Let's go ahead and use that information to actually tackle some of these problems down here. All right, so in part B, it does say we're going to go ahead and find the total perimeter of this fence measured in units. And then once we do it in units, we're going to go ahead and find the perimeter of the actual fence. So again, this is just a blueprint or a sketch of it. It's not the real thing. So we're going to go ahead and figure out the actual perimeter of this in real life. If each of these units on the coordinate plane is representing 4.5 meters in real life. And then we're going to make sure we do these in units as well as meters. So what is our formula for perimeter when we're measuring in units here? Well, let's see, for the perimeter, that is going to be all the way around the outside. So there's 2 of those lengths, right? And then there's going to be 2 of those widths. So we can say 2 of the lengths plus 2 of the widths. This would be a formula we could use here. So the perimeter can be 2 multiplied by what? Well, what do we say the length was? I think that we said the length here was 16. So we could say 2 multiplied by 16 units. And then we also are going to have that we have 2 multiplied by, what was the width? The width was, I think, yeah, 7 units. Okay. So we have 2 of these 16s and we have 2 of these 7s. And if we go ahead and figure that out, 2 times 16, that's going to be 32 units here, plus 2 times 7, that's 14 units. And so 32 plus 14 is going to be 46. So the perimeter here all the way around is going to be 46 units around. So let's go ahead and put this as 46, and it's going to be units. All right, now what if we wanted to go ahead and find this out in meters? Well, we have to see what the conversion is here, or what it's representing. So we see that it's going to be 4.5 meters is going to be each of these units. So we can do a couple things here, but I think what I'm going to do for this particular one is just take this 16 units we have here. So let's do the length here. That's equal to 16 units. But let's go ahead and multiply that by 4.5, right? If we multiply this by 4.5, times 4.5, that's going to let us know what this is going to be in terms of meters, right? Because each of these units is representing 4.5 meters in real life. So 16 times 4.5. If you go ahead and do that, I'm just going to write it down as 16 and then 4.5, or ignore it, just say it's 45 for now. That's going to be a 0, a 3, it's an 8, it's a 24, it's a 2, it's a 6. Go ahead and add these together. That's going to be 0, 2, 1, 7, 1 decimal place. So this is going to be 72 meters. That's going to be the length here. Okay. What about the width? Well, the width here we know is 7 units, but we're going to convert it to this meters. So each of these 7 units, we got to multiply it by 4.5. And so let's say we have 7 times 4.5, which is just 45 times 7. And then we'll put the decimal back in just a moment. That's going to be a 5 and a 3. I think that's going to be 31.5. So this is going to be 31.5 meters in terms of the width. So 7 units is representing 31.5 meters. Alrighty, so let's go ahead and redo this problem, but this time we're going to be using meters. So the perimeter is equal to 2 times the length here, plus 2 times the width. So the formula stays the same. Okay, what we're going to do is we're going to use different values here because we're going to be in meters instead of units. So it's going to be 2 times, what did we say that was going to be? I think the new one was 72. Yeah, 72 is going to be in meters. And then plus we have 2 of these, what, 31.5s? 31.5 meters. And so we're doing the same thing, just measured in a different unit here. So the perimeter is going to be 2 times 72, which is going to be 144 meters, plus 2 times 31.5, that's going to be 63 meters. And if we add these together, we're going to get a total of 207 meters. So the perimeter of this fence is going to be 207 meters all the way around. That's going to be in the real life measurements, not just on the sketch. Now, a shortcut you could have done as well is you could have taken this 46 here and just multiplied this by 4.5 because this is in 1 dimension. So you can go ahead and just do that as well, and that'll get you that 207 just in case you wanted to use that method instead. All right, let's take a look at part C. For part C, we're actually not going to be doing the perimeter anymore. We're actually taking a look at the area, and we're just being asked to figure this out in 2 different types of measurements. We have square units, and then we have square meters, right? So we're doing it based on the sketch and then based on in real life, and then we're going to make sure we include units as well. So what's the formula for area? Well, for area, it's just going to be length times width. So let's do length multiplied by width. And let's go ahead and do it maybe in square units first. So what did we figure out the length was going to be? I think we said the length was 16 units. Again, we're back to units now, no longer meters. and then multiply that by the width, which is going to be 7 units here. All right, so area is going to be a little bit quicker here as long as we're just multiplying. So the area is going to be 16 times 7. That's going to be 112 units squared. All right, so that's going to be 112 square units, or we can just write units squared. So I'll put a U and a squared here. So on the sketch, the area is going to be 112 units squared, but what about the area of this play area in real life in square meters instead? Well, the formula stays the same. It's still length times width. We just have to use the measurements in meters instead. So what's the measurement in meters? Let's go ahead and just use this over here. It's 72 and 31.5. Let's go ahead and say it's going to be 72 meters here, and let's multiply that by 31.5. So times 31.5. All right, so these are going to give us the measurements in terms of square meters instead of square units. All right, feel free to go ahead and pause and go ahead and write out that multiplication, but this should get us an answer of 2,268, and that's going to be meters squared here. So I'm going to go ahead and write, that's going to be 2,268 meters squared. All right. Now, if you wanted to go ahead and just use this 112, you can do that and go straight to this answer here. What's the conversion though, going from units squared to meters squared, or square units to square meters? Over here on the left with perimeter, it's one dimensional, so we just multiply by 4.5 one time. But here we're gonna have to multiply by 4.5 and then times that by 4.5 again. So you have to make sure you multiply it by 4.5 twice, which is essentially what we did when we multiplied this by 4.5 to get 72. And multiplied 7 by 4.5 to get 31.5. So if you wanted to go straight from this answer to this answer, just go ahead and take this 112 and multiply it by 4.5 twice, and you'll get this area in square meters. And again, it's because it's two-dimensional instead of one-dimensional. All right, here is number 8. Here's another similar one, so let's go ahead and try this. If that makes sense now, if you haven't tried number 8, then maybe pause and try it now that you have seen how 7 works. So it looks like Princeton High School is installing a fence, so it's very similar here, and it's going to be around a new hexagonal field. So if it's hexagonal, that means it's going to have 6 sides here. I'm going to go ahead and write that down. It's going to have 6 sides. Okay, and so students can safely play outside next to a busy street. It looks like they're going to be installing this fence and sketching it on a coordinate plane here. So very similar to the last one, we just have 6 points or 6 corners instead of 4 like the last one. Let's go ahead and plot these down. So for point P, what's going to be at -3, 8. So that's going to be in quadrant 2. Let's go ahead and plot that. It's going to be right around here. That's going to be P. What about corner 2 is -3, -5. That's going to be somewhere down in quadrant 3. That's going to be L. Let's see, for A, it's going to be 6, -5. So go over to the right 6 and then down to -5. That's going to be A. And then for corner 4, we have 6, 1. That's going to be up here in quadrant 1. That's going to be Y. Then we have 9, 1. That's also in quadrant 1. That's going to be point E. And then we have R, which is going to be 9, 8. So that's going to also be in quadrant 1, and that's going to be point R. All right, so that's the last 2 points here. Let's go ahead and connect these points to show where the fence is going to be. So here's a sketch of this fence that we have here. So these lines are representing where the fence is going to be installed. And the play area is inside the fence here, and all those little squares represent the square units where the students can actually hang out. All right, let's start off with finding the length of P to L. So notice how they're in different quadrants here. This is 8 and this is at -5. So let's see, from P to L, they're in different quadrants. The absolute value of 8 plus the absolute value of -5. So that's just going to end up being 8 plus 5. And so we know the distance there is going to be 13 units. All right, so what about from L to A? From L to A, they're also in different quadrants. We're at -3 and we're going to 6. Okay, so this is from L to A. And let's go from -3 to +6. They're different quadrants, so make sure we add their absolute values, right? So it's going to be 3 plus 6. That's a total of 9 units apart. All right, next we're going to go from A to Y. That's from here to here. Now A is down here at -5, and then Y is over here at +1. They're different quadrants. So this is going to be from A to Y. It looks like A is down at -5, and y is at +1. So again, they're in different quadrants, so let's add their absolute values. So that's going to be 5 plus 1, and that's going to be 6 units. All right, next we have from Y to E. They're in the same quadrant, so we're going to do something a little different here. So let's see, this is at 6 and this is at 9. So to get the distance between Y and E, let's go ahead and subtract their absolute values, the bigger one first. So it's going to be 9 minus the 6. So 9 minus 6, or the absolute value of 9 is 9 minus the absolute value of 6, which is 6. That's going to be 3 units apart from Y to E. Next, we have from E to R. These are also in the same quadrant. E is going to be at +1 here, and R is at +8. So same quadrants. So this is from E to R. So let's go from the absolute value of 8. That's the larger absolute value minus the smaller one, which is 1. That's going to be 8 minus 1. That's going to be 7 units apart. That's going to be from E to R. And then last but not least, we have one more point here from R to P. So kind of finishing off the shape here, R to P, that's going to be from here all the way to here. They're in different quadrants, so R is over here at 9 and P is over here at -3. So they're in different quadrants, so it doesn't matter which one we write first. We're just adding the absolute value, so it's going to be 9 plus the absolute value of this -3. 9 plus 3 is going to equal 12 units. Alrighty, so now that we know all the measurements here, we can go ahead and actually figure out the perimeter. So the perimeter, there's no great formula we can really use here. We're just adding up all the measurements. So let's see, we have 13, 9, 6. We have 13 plus 9 plus 6. And what else do we have? 13, 9, 6, 3, 7, 12. So we're going to have 3, 7, and 12. Let's see here. 13 plus 9 is 22. 22 plus 6 is going to be 28. Plus 3 is 31. 31 plus 7 is going to be 38. 38 plus 12 is going to be, I believe, 50. So I think the perimeter here is going to be 50 units all the way around this shape. So 50 units, I believe, will be the perimeter. All right, so that's the perimeter in the sketch here, but what's the perimeter in real life? Well, you gotta keep in mind here that each of these units on the coordinate plane here is representing 3¼ feet in real life. So we could convert this to feet, 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 and this to feet, and do it 6 different times and then add those up. Or we can say, because this is one dimensional, because we know this is 50 units all the way around, we can multiply this by 3¼ and that'll tell us the new perimeter, or the actual perimeter in real life, measured in feet, right? So we can take the perimeter and we can say we know it's 50, right? And let's multiply this by 3¼ Okay, so let's go ahead and multiply this by 3¼ 50 as a fraction is going to be 50 over 1. What's 3¼ as a fraction? 3 1/4 is going to be 13 over 4. 13 over 4. And then I think we can cancel a little bit here, but not that much. 50 and 4 are both even numbers. So let's do 2 times 5 times 5. 13's prime, so leave the 13 alone for now. On the bottom, we have 1 multiplied by 2 times 2. Notice how these 2's can cancel out, but that's just about it here. So the perimeter, we can say, is on top. We have to do 5 times 5 times 13. That's going to be 325. And then on the bottom here, 1 times 2 is going to be 2. So you have 325 over 2, which is as a mixed number. If you want to do the long division, feel free to do that. That's going to be 162 and 1/2. And then this is going to be measured in feet now. All right, so we just went ahead and took that 50, and then each one of those units represented 3¼ feet in real life. So if you were to figure out the length of this fence all the way around, it's going to be 162¼ feet. All right, so while we just took care of the perimeter, let's now go ahead and take a look at the area. We're going to go ahead and do this in square units and then in square feet. All right, so for the area, this one's going to be a little more interesting than the last problem just because we have kind of 2 shapes here. It's up to you how you want to break this up. I think what I'm going to do is I'm going to break them up into 2 rectangles looking like this. So I'm going to have this top rectangle and this bottom rectangle. So for this top one, I think the length here from P to R, we already know that's going to be, let's see, P to R, that's R to P, that's the same thing, right? That's going to be 12. So this measurement here is going to be 12. I'm just going to go ahead and write that in as 12 units. And then what about from R to E? I think we already figured out R to E. That is E to R, which is 7. So this top rectangle is going to be 12 by 7. And what about the bottom rectangle? Well, we need to figure out this part here, which we don't have like a dot here, but that's okay. We know L to A is the same thing. So L to A here is going to be 9 units. So I'm going to go ahead and write that in as 9 units. And then how tall is this rectangle, or what's the other dimension? Well, we can just use A to Y. A to Y is going to be 6 units. Okay, so we have the dimensions of each of these. This top rectangle is going to be 12 by 7. And then this bottom rectangle here is going to be 9 by 6. That's all we really need to find the area here. So let's do 12 by 7 first. So the area for the first one is going to be its length times width. So let's say that's going to be 12 units multiplied by 7 units. 12 by 7, that's going to end up being 84 units squared. That's for that top rectangle, right? What about for that second rectangle? That's going to also be length times width. But this time it's a slightly smaller rectangle here. I think the top one was 12 by 7. This is 9 by 6. So let's go ahead and multiply 9 units multiplied by 6 units here. So 9 by 6 is going to be 54. So it's going to be 54 units squared. So again, these are the square units for each of the individual rectangles. So let's see, if we want to find the total area, make sure we add these two areas together to figure out the entire area. So it's going to be this 84 units squared plus the 54 units squared. Now, if we add those up, we're going to get a total area here of 138 square units. So that's the total space inside this shape if we measure it in square units, which is what we have on the sketch. All right, now the area in square meters is going to be the one that's going to take a little bit more thought process here. So remember earlier we just multiplied the perimeter in units to get in meters and just multiplied it by 3 1/4, right? Because that was the conversion. But this time we're going to do something similar, but we have to do it 2 times because remember area is a 2-dimensional measurement here. So we have to change the units to meters in both the length and the width, or in 2 dimensions. So we have to times it by this 3 1/4 twice. So that's really 3 1/4 squared, or just multiply it 2 times here. So what we can do here is we can take the area. Let's go ahead and write this down here. The area we know is going to be 138, but we're going to multiply it by the conversion 2 times for each of the dimensions. So it's going to be times 3 1/4, and we're going to times it by 3 1/4 again. All right. So make sure we do it 2 times when we're converting in area to a new dimensional area. So 138 as a fraction is going to be 138 over 1. And then if we take each of these and write them as improper fractions here, it's going to be times 13 over 4. 13 over 4. But we have another one here, so it's times it by 13 over 4 again. All right, let's see if we can break this down a little bit. So 138 can divide by 2. So it's going to be 2 times 69. 69 is going to be 3 times 23. And then it looks like we have times 13 times 13. All right, so that's going to be the numerator here. And on the bottom, it looks like we have 4 times 4 times 1. So we have the 1 here, and then we have 2 times 2 times 2 times 2. All right, so what can cancel out? It looks like just this 2 and 2 can cancel out. Nothing else really can. So if we go ahead and multiply on top, 3 times 23 times 13 times 13. All right, now feel free to pause and do the multiplication out to go ahead and make sure you feel comfortable doing that. We should get 11,661 as our numerator, and in the denominator, we should get 8. Now, if you go ahead and use long division to convert this improper fraction into a mixed number, we should get, that's going to be 1,457, and I believe the remainder is 5, so it should be in 5/8. And this should be meters squared. So I believe this measurement in square meters is going to be 1,457 and 5/8 square meters. All right, so that wraps up that problem. So let's go ahead and switch gears a little bit and just take a look at some operations with some rational numbers. All right, so for number 9, let's go ahead and find the sum. If we see this word sum here, that means we're going to be adding. So we have negative 14 plus 9. So for A, they are different signs here. So we're going to go ahead and subtract their absolute values. That's going to be 5. And we're going to take the sign of the number with the greater absolute value. For B, it looks like they are also one's negative, one's positive, just like in the last example. So we're going to subtract their absolute value. So that's going to be 6. And it's going to be a negative 6 because the negative 29 has a greater absolute value. If we take a look at C, these both have the same sign. So we're going to take their absolute values and just add them. So if they have the same sign, we add their absolute values here. That's going to be a 12, carry the 1. That's a 10, carry the 1. I believe that's going to be 10.02, but a negative plus a negative is always negative, so we're going to have negative 10.02. For letter D here, these two decimals have different signs, so let's go ahead and subtract their absolute values. So we have 8.34, and let's go ahead and subtract 4.84. All right, so again, if there are different signs, we need to subtract their absolute value. That's going to be 0. That's going to be a 7. That's going to be a 13. 13 minus 8 is 5. And 7 minus 4 is going to be 3. So we're looking at 3.5. And is it positive or negative? Well, the 8.34 has a greater absolute value, so we know it's going to be positive. All right, for letter E, it looks like we have two of the same sign. So a negative plus a negative is always going to be more negative. If we go ahead and write this out, it's going to be negative 13 over 6 here. Let's put the negative on top. Plus we have a negative 7 over 6 here, right? So let's go ahead and add two negatives. Negative plus a negative, let's do 13 plus 7 is going to be 20. So it's negative 20 over 6. To divide top and bottom by 2, we should end up with negative 10 over 3. But if we go ahead and convert that to a mixed number, that's going to be negative 3 1/3. All right, so that is going to be our final answer here, or the sum. For F here, it looks like we are adding two fractions that have different signs. So we have to subtract their absolute values, but let's go ahead and write this is going to be 11 over 8 plus, and then move the negative to the top. So it's negative 13 over 8. So let's see here. They're different in terms of their signs, 11 and negative 13. So subtract their absolute values. 13 minus 11 is going to be 2, but it's going to be negative because this negative 13 has a greater absolute value. So it's negative 2 over 8. Then we can divide top and bottom by their GCF of 2. So it's going to be negative 1 over 4. So our final sum here is going to be negative 1/4. All right, now that we practiced adding here, let's go ahead and practice subtracting. Make sure though, the directions here say that we're gonna find the difference, which is the answer to a subtraction problem. But we have to make sure that we are going to go ahead and rewrite each of these differences as a sum first, right? So turning all the subtraction problems into addition using the additive inverse property, or you can think about it as keep, change, flip. So 5 minus 14 is the same thing as 5 plus negative 14. That's gonna be the sum. All right, and these are different signs now. So we're going to do 14 minus 5, 14 minus 5, just because they are not the same sign, and that's going to be 9. And then we know it's going to be a negative 9 just because negative 14 has a greater absolute value. For B as a sum, this is going to be negative 8 plus negative 21. All right, these have the same sign, so we're just going to add their absolute values. 21 plus 8. That's going to be 29. So again, when they're the same sign, you just add their absolute values. So we have negative 29. Moving on here, we have some decimals. Rewriting this as a sum, it's going to be negative 6.9. Adding the opposite of this one, that's going to be a plus a 7.8. Notice how these have different signs now. So we're going to subtract their absolute values. 7.8 it has the greater absolute value. So we're going to take away 6.9, which has the smaller absolute value. We got to borrow here, make that a 6, make that a 18. 18 minus 9 is 9, and this is 0.9. Now, is it positive or negative? It's going to be positive here just because the 7.8 has a greater absolute value than the negative 6.9. Looking at D, let's go ahead and rewrite this as an addition problem. It's going to be negative 5.23 plus the opposite of this. So flip to the negative here, it's going to be negative 6.98. All right, these are the same sign. They're both negative, so negative plus a negative is always going to be negative. Let's go ahead and add their absolute value. So 5.23 plus 6.98. If you go ahead and add these, that's going to be 11, carry the 1. That's 12, carry the 1. That's a 12. So I think it's going to be negative 12 and 21 hundredths. All right, for E, let's go ahead. We have some fractions here. Rewriting this as an addition problem, I'm going to move the negative up here as well. So it's negative 5 over 9. Let's add the opposite here. So that's going to be plus, and it's just going to be a positive 7 over 9. So that's kind of nice. This definitely looks a little bit cleaner. So if we add those numerators together, negative 5 plus 7, they're different signs. We have to do 7 minus 5 is 2. And then it's going to be a positive 2 just because 7 has a greater absolute value than negative 5. Moving on to F here. If we take a look at F, let's go ahead and turn this subtraction into an addition problem. So I'm going to leave this 13 over 8 alone. And then let's go ahead and add the opposite. So it's plus, and then the opposite of 23 is going to be a negative 23. So it's negative 23 over 8. Okay. And then let's see. Let's add 13 and negative 23. They have different signs. We have to subtract their absolute values. 23 minus 13 is 10. And it's going to be a negative 10 just because the negative 23 has a greater absolute value. Dividing top and bottom by the GCF of 2, that's going to be negative 5 over 4. And then as a mixed number, this is going to be negative 1 and 1/4. All right, number 11, let's go ahead and switch gears here. Let's go ahead and find the product. So if we're finding the product, that means we are multiplying some values together. So remember, for all of multiplying and dividing rules, you just ignore the signs altogether, and then you count how many negatives you see, and each negative is really just the opposite. So for A here, we have 14 times 53. So let's go ahead and just take the time to multiply this out. That's going to be 12, carry the 1, that's 3 plus 1 is 4. Placeholder 0 and a 2, that's going to be a 7 here, I believe, right? So if we go ahead and add these together, we have a 2, a 4, and a 7. So I think this is going to be 742. But again, it's going to be the opposite of this 742. Just because there's two negatives here. And so the opposite of the opposite is just going to be 742. And hopefully that makes sense because a negative times a negative is a positive. All right, for B, we have 47 times negative 624. So again, just ignore the negatives first when you're dealing with these and just multiply their absolute values and then think about the negatives afterwards. So we go ahead and multiply here. That's going to be an 8 and a 2. It's a 6 and a 1. And I think 43. That's our first partial product. On the second row, I believe we should have a 6 here. Carry the 1. That should be a 9, I think. And then a 2 and a 4. If we go ahead and add these two partial products together, I believe we should have an 8. Then we should have a 2. Carry the 1. Then we should have a 3. Carry the 1. A 9 and a 2. All right, so how many negatives do we see? We just have one negative. So it should be the opposite of whatever this product is of 2, 9, 3, 2, 8. And so I believe the answer here is going to be the opposite of that. So it's negative 29,328. All right, for C here, it looks like we're multiplying a decimal by a whole number. So let's go ahead and ignore the decimal for a moment and just think about this as 64 and multiply that by 79. All right, we'll put the decimal in just a moment. I believe this will be a 6, carry the 3. 54 plus 3 is 57. So check to see if you have 5, 7, 6. And then 7 times 4 is 28, carry the 2, 42 to 44. Let's go ahead and add these partial products. I believe we should have a 6, and then a 5, and then a 0, and then a 1. And then we need to put one place value or one decimal place value in here. So we have one negative in the problem, so we're gonna have negative, let's see, 505.6, all right, because the decimal is going to go right here. So it's the opposite of 505.6, which is going to be negative 505.6. All right, for D, we have 5.38 multiplied by 6.8. Just like before, we can go ahead and ignore the decimals here. So just think about it as 538 multiplied by 68, right? So let's go ahead and multiply these two whole numbers and then think about the decimals and the signs after. So I believe this is a 4, put a 6 here. 0 and a 3. I believe this is going to be a 43. I think that's the first partial product here. Make sure you have a placeholder here. Put an 8, put a 4 up here, put a 2, and a 2 over here. I believe this is 32. Adding these, we have a 4, then an 8, then a 5, then a 6, then a 3. And I think we have 3 decimal places we ignored, so I believe this should be the opposite of 36.584, and so it's going to be negative 36 and 584 thousandths. All right, on to a couple fractions here. For e, looks like we have a proper fraction multiplied by an improper fraction. So let's go ahead and think about this. Well, we know the answer is going to be negative something. So let's go ahead and just put that first here. Let's go ahead and break these down so we don't have to multiply big numbers together. So 24 is really the same thing as 2 times 2 times 2 times 3. And then 35 is really the same thing as 5 times 7, right? Those are the prime factorizations. 25 on the bottom is just 5 times 5, and 28 is 2 by 2 by 7. All right, so what can we cancel out here? Well, the 7s can definitely be canceled out. These 5s can be canceled out. This 2 with this 2, and this 2 with this 2. So it looks like after all that canceling out, 2 times 3 is left on top, which is 6. And we have a 5 left on bottom, so this is 6/5 or 1 and 1/5. So we have the opposite of 1 and 1/5. And so the answer here is just -1 and 1/5. For f here, looks like this one we have a negative fraction times a negative, so the answer is going to be the negative of the negative, or the opposite of the opposite here. Let's see if we can break this down though, so that we can see if we can avoid doing some big multiplication here. So 21 breaks down to 7 times 3, 16 breaks into 2, 2, 2, and 2, 32 on the bottom breaks into 5 2s, and 14 breaks into 1 2 and 1 7. Okay, so let's see, we have 4 2s on top, can cancel out with 4 2s on bottom, and then 1 7 and 1 7 can also cancel out. So in the numerator, we're just going to have 3, and in the denominator, we have 4. So the answer here is 3/4, but we had 2 negatives multiplying, so it's the opposite of 3/4, which is really just 3/4. All right, let's try just a few more practice problems here. And these last ones, we're actually going to be talking about division because it says the word quotient here. So let's make sure we feel comfortable dividing. All right, so for A here, we know we have a negative divided by a positive. So we know the answer is going to be the opposite of whatever we get when we ignore the decimals. So let's see, 429 divided by 3. It's going to go in once. 1 times 3 is 3. We have a remainder of 1. Bring down this 2. 4 times 3 is exactly 12, remainder of 0. And then 3 into 9 exactly 3 times, so the remainder here is 0. So I think we can get 143, but we're looking for the opposite of that, so this quotient here is going to be -143. Okay, moving on to B, we have a -728 divided by a -4, so the answer here is going to be the opposite of something. Okay, so what are we dividing? So just ignore the negatives now and just take this 728 and let's just divide by 4 and think about the signs later. 4 into 7 once. 1 times 4 is 4. 7 minus 4 is 3. Bring down the 2. 4 into 32 is going to be 8. 8 times 4 is exactly 32. We have a remainder of 0. Bring down this 8. 4 into 8 is 2 times. We have a remainder of 0. So we have the opposite of 182. And the opposite of that is just going to be 182. And that makes sense because a negative divided by a negative is a positive. Let's try C. For C here, we have a decimal divided by a decimal. It's a positive divided by a negative here. So the answer, or the quotient here, is going to be a negative value. So let's go ahead and do that. And also when we're dividing, we prefer our divisor here to be a whole number. So it's times that by 10 or multiply it by 10. And if we do that to the divisor, we should do that to the dividend as well. So the real division problem we just have to think about is going to be 524.4. And we're dividing that by just 6, right? So that's going to be a little bit easier to deal with. The decimal in this is just going to be right here. So 6 into 52 is going to be an 8. Put the 8 above the 2 there. 8 times 6 is 48. So if we subtract here, we're left with 4. Bring down this 4. 6 into 44 is going to be 7. 7 times 6 is 42. We have a remainder of 2. And then bring down this 4. 6 into 24 is going to be 4. 4 times 6 is 24. We have a remainder here of 0. So we're going to have 87.4. Now, the answer is going to be the opposite of that, so it's going to be negative 87.4, and that's going to be our quotient. All right, for D, we have negative 106.76 divided by this positive 1.7. We have one negative here, so our quotient is going to be negative. But negative what? Well, our divisor here, we want to make it a whole number, so it's multiplied by 10. Let's go ahead and do that to the dividend as well, multiply that by 10. So we really have 1067.76 0.6. That's going to be our new dividend here if we're dividing it by 17 instead. So let's put the decimal right up here. 17 into 10, 106, I think is going to be 6 times. 6 times 17 is going to be, I think, 102. 102. So 106 minus 102 is 4. Bring down the 7. 17 into 47 is going to be 2. That's going to be 34. And we're left with 13. Bring down the 6 here. 17 into 136 is exactly 8 times. 8 times 17 is 136. And the remainder here is 0. So we have this negative 62.8, or the opposite of it, which is just going to be negative 62.8. All right, for E, it looks like we have a negative fraction divided by a negative fraction. So the answer here is going to be the opposite of whatever fraction we get here. And so let's see, let's just look at their absolute values here. So we have 8/9 divided by 12/15, right? So just ignore the signs for a moment. We turn all our division of fraction problems into multiplication, a different kind of keep, change, flip here. So 8/9. We can use the multiplicative inverse property and say this is times 15/12, right? Now, what is 8 broken down into? 8 is going to be 2 times 2 times 2. 15 is going to be 5 times 3. The 9 is 3 times 3, and the 12 is 2 times 2 times 3. All right, so the 2 and the 2 up here cancel with these 2's down here. And we can do a 3 and a 3 here. So I believe on top, this would just be 10/9, which is going to be 1 and 1/9. So the quotient here is going to be 1 and 1/9, but we know it's the opposite of that, which is just going to be positive 1 and 1/9. So just because a negative, or the opposite of the opposite is the original, I'm going to put a box around that because it's a little bit cluttered here. All right, last one for F here. We have a positive fraction divided by a negative fraction. So we know the answer here, or the quotient, is going to be a negative value. Let's go ahead and ignore the negatives here and then just take a look at what is 60/42 divided by this 45/28. Again, ignoring their negatives. If we turn this into a multiplication problem, this is going to be 60/42 multiplied by 28/45. Again, we can turn all division problems into multiplication. If we multiply by the reciprocal of the second fraction, I think we're going to have a lot of factors here. So 60, I think, is 6 times 10. 6 is 2 times 3. 10 is 2 times 5. 28 is 4 times 7. Let's see, 4 is 2 and 2. 42 on bottom is 7 times 6. 6 is 3 times 2. 45 is 3 times 15. 15 is 3 times 5. So I believe these are all the prime factors. Let's see, the 7 and the 7 can cancel out nicely. The 5 and the 5 as well. This 3 and this 3. Let's see, a 2 and a 2. And I think that's just about it here. On the numerator, we have 2 times 2 times 2, which is 8. And in the denominator, we have 3 times 3, which is 9. So this quotient here is 8/9. But because it's a positive divided by a negative, we have a negative 8/9 as our final quotient, because it's the opposite. All right, so there you have a pretty extensive review here on, first of all, absolute values and opposites, distance and plotting points on a coordinate plane, a little bit of area and perimeter as well. And then we also talked about some operations with rational numbers. So what I mean by that is just whole numbers, fractions and decimals, and dealing with positives and negatives, where we practice adding, subtracting, multiplying, and dividing. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And remember, if you would like to download a free copy of the blank PDF or the answer key PDF, you can find a link to that in the description box below, and you can take a look at that and see if it's helpful. As always, keep up the great work that you're already doing, and I'll see you in the next one.